This is where things get fun. We're going to talk about the stretch reflex, which is an example of this is the knee-jerk reflex. Other places in your body will respond to stretch similar to your quadricep muscle, but we're going to be looking at that knee jerk, which is stimulated by the quadricep, as our example. We're going to be using the components of our reflex that we talked about previously in terms of that basic pathway that reflexes use, but now with some more specifics. So let's start with the anatomy that we need to know. So I want you to label everything you can in this image here. We've got the spinal cord, of course, and we've got the dorsal horn and the ventral horn. Do you see the dorsal root ganglion? I got distracted by saying that. Dorsal root ganglion. I'm going to put arrows to all these things in just a moment. Label as much of the spinal cord as you can. Then let's go over here. Do you know what bone this is? This is your tibia. Here's the tibial tuberosity that you saw in lab. Up here would be the femur. And this would be a quadricep. Either there's 4 quadricep muscles. This would be the muscles. And then what is this yellow thing here, do you think? That's the patella. And this yellow one is going to be the patellar ligament. So here is the labeling, everything that you should know from previous lectures. And now we're going to look at what happens. So the knee-jerk reflex starts when there's a hit to this patellar ligament. So step 1 in the reflex pathway, of course, is going to be receptor. The receptor is actually within the quadricep muscle. It is going to be a receptor that detects stretch. So a stretch receptor. We'll talk more about these specifically in a moment. Actually, let's put here, that's step 1. That information is going to be carried to the spinal cord. So let me get my drawer here. There is actually little stretch receptors. Oops, that's the wrong color. There are little stretch receptors that are going to detect this, little dendrites that are going to travel to the spinal cord. This is actually going to be in the ventral ramus and to the dorsal horn eventually. Where's our cell body? Right here. This is an afferent sensory neuron that's carrying the information to the spinal cord. This actually is going to go all the way here. This is what is considered an ipsilateral and monosynaptic reflex. There's only going to be one synapse in the pathway. What that means is this information is going to synapse with a neuron right here in the ventral horn. What kind of neuron? A somatic motor neuron. So this is going to tell this neuron, hey, we just got stretched. This is called integration. So step 2 is going to be sensory neuron. Because integration, so integration is really that second step so that the motor neuron can be that output signal, right? Here's the output signal, which is down here, that somatic motor neuron telling the quadricep muscle, I'm just going to go around this way in terms of anatomy, a little bit more accurate, telling that muscle to fire, to contract. You know, muscles fire, have action potentials before they contract. So step 3 is going to be our response. the target, the quadricep, step 3 is that quadricep muscle contracts to have the knee kick. So this is what that looks like in a diagram as well. Another one. Here is that stretch reflex. The receptor here is a muscle spindle that I'll talk about in just a moment. This information is going to be travel through the sensory division, posterior root ganglion to the spinal cord, monosynaptic, ipsilateral, because the quadricep on the same side of the body is going to be the effector, the target or effector, which is going to then contract. That's that response. This nerve here is actually the femoral nerve. That's where this is going to occur. So we're going to, by taking the patellar reflex, the doctor is checking the integrity of your femoral nerve as well as where that processing occurs in the spinal cord between L2 and L4. Why is it more than one place? Well, because the femoral nerve member comes from a nerve plexus, which originally originated from more than one spinal nerve, so more than one place in the spinal cord.